Okay, today main agenda is getting some more idea about what we'll do in real time. So once you get into the project, so what are the things we'll do and how the project flow will be there, and some of the questions like what is the data size and what is the cluster sizes. So that kind of the things I will try to give more idea on that one. So this is the main agenda of this one means so getting some more real-time experience and real-time kind of the idea about what generally do it in Hadoop real time and a little bit exposure and production clusters I will give a little bit. Yeah. Coming to the first activities, project activities. So if you take any project, yeah, if you take any project, so we need to start with like a few things. So first is what is the data and what we need to do with that data and how we need to load that data. So first step, if you take any kind of Hadoop project, first step is data. So if you want to do some analysis or if you want to find some meaningful insights or if you want to find the whatever analysis or if you want to find the useful information or if you want to visualize something. So if you want to start any project, first thing is we need first one is loading data into Hadoop. So first step is loading data into HDFS. So if you want to load the data, so generally the data it will be where it will be there and how we can get the data. So that is the first step we need to take care about while doing the project. So see first point is suppose if my data is in remote mission or remote missions if I have the lot of log files or some other kind of the information I have as a files like text or JSON. If I want to load the into Hadoop, so first what I need to do is first I need to load into local machine and from there I need to load the HDFS. So before loading into HDFS, first thing is loading into local machine. So that nothing but either whatever the machines we are using for the cluster like Linux and Windows, we need to load the data. So for that one, we need to use how we can do with the SFTP and NSF. So loading the data from remote to local, so we need to use SFTP or NSF. So these are the tools for loading the data from the remote missions to local mission. So these tools very helpful for loading large data also in real time. So they will use generally we will use this SFTP and NFS. And next step is so loading a local data to the HDFS using we have different ways to loading into HDFS like HDFS command, HDFS Java API, and we have the Hue tool also there, kind of UI for the loading the data. So instead of the command, so we can load through UI also we can load it. So that is one of the so after that after loading the data, so suppose if I have the data and I have loaded that is suppose a text file or any kind of file, so I don't want the for getting the meaningful information or if you want to analyze the data, so I don't want the full data. So from that I need to get or I need to extract the few fields. That means what are the fields I'm going to analyze, so that I need to get. So this second step is extracting the data from the files. So that means if you have a data as text or text data like CSV, JSON, Avro, XML, so that data we can extract and we can write the queries and these kind of data in Hive we can write it. So I think previous classes, whenever we are in training classes, we are discussed about so how we can load different kinds of data into Hive. So if we have the data as a text file, and in that we have the data like a CSV, JSON, and Avro, we have the data like that. We can load into Hive and we can process it. So what are the fields are needed? So that only we will extract and these files. And if you have data as a Word, Excel, PDF, and images kind of things, so we can extract by writing the MapReduce programs. We can extract. So after loading the data, so we need to how the data it will be there. We need to check, and based on that, how we can extract the fields. What are the fields is there? So that is the second step. We need to do it. So if we are able to handle with the Hive opaque, we can handle it. So some of the files we are not able with the tools. We need to write the code like MapReduce code. So in that point of view, so we need to write the MapReduce code in any one of the language like Java or Python. We need to write it. Next is after extracting data, so I got the fields. Suppose my input data is logs data, and that I need only the few information like IP and what is the page names, what are the pages are edited by the user, and what is the page sizes, how many times it is visited. So that kind of information we have it. So I will extract the IP address and timestamp and what is the page name. I will extract. Apart from that, we'll have the other fields also, but we will extract what are the fields we needed. So after extracting the data, so we will load the data into Hive, or we'll have data in as a HDFS. So that data we need to analyze or process the data. So for that one, we can use the tools like Hive, Pig, MapReduce, and Impala also we can do it. So whatever we are discussing this Hadoop until now we have discussed in training classes. So those are related to the bulk or batch data only. So what is bulk or batch data means, we are not processing single message. We are processing bulk. I have the 1 GB or I have 1 TB of data, load it and process it. So that is what I will do it in batch or bulk processing. So apart from the bulk or batch processing, any other processing is there? We'll discuss end of the thing. We'll discuss that one. Yeah. So loading and extracting, analyzing completed. So finally I got the data as a analyzed data. So that is fine. But I want to schedule this one. So if I want to move this one, so simply if you're copying manually the Hadoop data into HDFS, or extracting the files and writing the MapReduce and running the manually, or either Hive or Pig scripts, copying manually to the machine and running manually. So that is the not the automation or the production one. So for that we need to define the workflow. So first, what is the step from where the where the data needs to be landed in the HDFS, and what are the things we need to do after the loading the data. So which component it will take care about extracting, and which one it will take care about the analyze. So all these steps will make a workflow, and we will schedule. So the scheduling, it will be, we can do it by using writing the Linux shell scripts and doing the cron job. We can do it. And Hadoop itself, we have the component like Woozy. So that is makes very easy to writing the workflows and scheduling it. So we can schedule daily or weekly, we can schedule it. And so the finally what we will do is visualizing the data. So mostly the visualizing data, the whoever working on the Hadoop, so they won't take care about that. For this we'll have the separate team, so who have idea about who have experience on the like visualization technologies or the reports. Mostly they will take care about that one. So like finally we need to visualize the data as a graphs and charts using Tableau or ClickView, and generate reports and dashboards using like Java framework. JSF and Spring. So generally, if you take any real-time project, so these are the steps we'll do. Apart from that, after getting the data, we'll have the some more advanced things like predictive analytics, machine learning. So those are very advanced concepts. But if you want to start with the big data and Hadoop, so initially what we'll do means, so if you want to start any project with Hadoop, so generally we'll follow this one: loading the data and extracting, analyzing, and define the workflow and schedule the workflow and visualizing the data. Next slides I will have one presentation. So there you will get more clarity, more details on next slides. Okay, I have defined few project flows. So these are on my experience base. I have seen different kinds of flows. So apart from this, we'll have the other flows will be there. But these are the main generally the flows how it will be there, how it will be there in production or how it will be there in real time. So these are the project flows it will be there. So first project flow I'm explaining like loading a text or JSON data files and analyzing the data with the Hive and store analyzed data into our DMS. So this flow is related like a loading normal text or JSON files and loading into HDFS and after loading analyzing with Hive. So Hive results data needs to be moved to the RDMS and finally we need to visualize the data. So this is the one project flow. Generally we'll use it in real time. And another project flow, it's kind of if you have the pig also. So instead of the Hive, so if you want to use pig, so how we can pig use and how if you want to visualize from the pig, how we can do it. Or if you want to connect it to any pig and Hive, so how we do, how we can do it. So those details we'll discuss in this project flow. Next project flow is kind of involving in NoSQL. So I think previous session or a demo session or initially we have discussed about. So big data is not related to only, so big data is not related to only the Hadoop. So we'll have the NoSQL databases also. So if you want to use NoSQL databases in Flow, so where we'll use, so that also this is one of the flow for the that how we can include the NoSQL database in our project. And for this, instead of the text or JSON files, for this project flow, just I take if we pass the Excel and Word files, so how we can do the flow, so that that I will show. So convert Excel data into CSV file and apply the transformations in Hive tables and load data into NoSQL database. So these are the different flows. So first we will go by one. So if you have any doubts in middle of that one, you can ping me or you can unmute and you can discuss. We'll discuss. Okay. First we'll started with normal the how the flow it will be the Hadoop project we'll see. So we will have the Hadoop 1 minute. Okay. So we will have the Hadoop cluster and so first the project initially we need to think about the where the data it will be there. So first suppose if we have data as a text or GZ files or JSON file, so we have the data in remote machine like a already generated data and offline data. So that means the files it will be arranged in day wise and hour wise. The data it will be there, like text file maybe we already everyone knows about the text file. And coming to the gz file, so some of the people maybe it will you already hear about this gz file. Gz file is kind of the linux related archive file. So directly if you want to process for the Hive, so we can directly load instead of text file we can load gz file also. It will take directly without doing any kind of operations. Directly it will take how we will load text file. So gz also it will same it will take. So what is the advantage of this gz file means, so it's kind of compression. So if you instead of loading text files will occupy more space, and it needed a lot of space for the storage. So that's why generally in linux missions, if you observe the you already have idea about that one. And generally it will be there in gz files, either text or gz it will be there. And we'll have the json files. Maybe if you suppose if our input data is JSON, so we'll have the files as a JSON files. So any one of the files it will be there. So suppose if I have the text files, so it will be in remote machine. And before going to that, so my data it is in remote machine as a text or gz files or JSON files. And first step what we'll do in Hadoop means we need to data storage. So for the data storage, what is the component in Hadoop is HDFS. So we will have the cluster, and on this one, so we need to load the data. So whatever the input data is there, so remote data, if we want to process anything, so we need to load the data into HDFS. So for loading the HDFS, as I said previous slide, so we need to do these two steps. First is loading remote data files into local machine by using SFTP or NFS. So SFTP is kind of a file transfer protocol. So S means secure file transfer protocol. So if you want to move large files we can move it. So NFS is very good one compared to the it's kind of a mounting. So physically it won't have the data. So it will just mount to the remote machine. So whenever we need data, so that it will pick up and it will load the data. So these are the two tools mainly we'll use for moving the remote data to the local machine. And after loading into local machine, we need to load into HDFS. So HDFS, how we can load it means, so by using HDFS commands, we can load the data into HDFS. So like this, whatever the data, so we can load it. So the first question for the any kind of the project is, so where the data it will be there. Suppose my data it is remote machine as a files. So whatever the files, maybe it is Excel or any kind of file, image files. So for loading data, we don't need to bother about anything. Just only we need to bother about the size of the file. Suppose if we have the large size, how we can fastly transfer the data to the HDFS. So that only we need to take care about. Other than the what kind of the file, so we don't need to bother about that one for loading data into HDFS. Okay, so next, so apart from this remote file, I have data in any other sources. I will get the data. Yeah, we'll get the data from the other sources like web server logs. Suppose if my website or application is running on web server, instead of creating the files in the remote machine, and it will take again the space. So we need to provide space for the storing the files also. Instead of the files, directly if you want to get the data from the server logs, we can load into HDFS. Anyone have idea about how we can load the web server logs directly to the HDFS? We have one component. Anyone having idea? Yeah. If I have the data from web server logs or the continuous data, so continuously we are getting from data, so we can load into HDFS. Yeah, I got answer from, I got answer. So the answer is Flume. Suppose if I want to load the data from the continuously getting like web servers, so I can load it by using the Flume. So we can load the continuous or streaming data from the web servers using Flume. So by using this step, so we don't need to create the files and directly we can load it. So that will be depend on the whether we need to directly connect to the web servers or we need to load from the remote machine. That will be depend on the sometimes customer also. So sometimes they won't allow the access for the directly connecting to web servers. So that time they will copy the files into some remote location. So we need to connect and we need to load it. So that will be depend on the sometimes customers also. And but if we want to do it in development, so we can connect it to any one of the web server and we can able to do that. So this is the remote file machine data and web servers how we can load it. Apart from that, we will have data it is in. Maybe can anyone tell from where the data it will come? Other data source? Can anyone guess or can anyone tell? So apart from the machine data and apart from web servers data, so before the Hadoop, mostly the where will store the data. Not Scoop. Scoop is correct, but the data source is MySQL. Yeah, correct. Databases. So now the one more the data source is RDMS or the EW. EW is nothing but enterprise data warehousing. So from there, if the data is there, so this step already we have discussed in previous class. So how we can load the data into HDFS? So Scoop. So by using Scoop, we can load the RDMS data into the HDFS using Scoop. Suppose if you got any question like that, what is the input data? What kind of the file formats will be their input and who will give the data and from where we'll get means. So any one of these source only mostly will get data. Either we need to get web servers or like social media REST APIs will get. That is also continuous data. If you take Twitter, so Twitter continuously will get the tweets if you connect it to the application. So either we'll get the continuous data or we need to load the remote files or we need to it will be there RDMS or EW. So it can so from there only we'll these are the different sources we'll use in real time. So if we anyone ask, so any one of these things we can tell. So based on your project and kind of the data, so which is suitable for the client, so that you need to tell. So this is about initial step how we can load the data from the different sources. After that, once we loaded the data, and here we need to question generally we'll get interview questions on this one HDFS like a cluster. So what is the data size and how much the cluster size? So that next slides I have prepared some question. So while discussing about that, we'll get more details about the cluster size and what is the distribution and how much data size is already existing in cluster. So daily how much data you will get. So these are the things it will be there in HDFS clusters. Next, after loading the data, so next step is we need to process or analyze the data. So for that we have the component MapReduce, and after loading data, my data is text or JSON file. So I can use Hive. So I can use Hive. So Hive also we don't have only one kind of tables. That means different kind of stages it will be there. So depend on the projects, we'll have the different stages of the tables. So this is the general terms. So this is not the technical the Hadoop suggested. So this is the whenever we are working, so generally we'll call it as a staging, main and result tables. So staging is nothing but a whenever we are landing or whenever whatever the data we are loading initially. Suppose if I want to load the JSON data, Avro data, so that data apart from the necessary or wanted whatever the fields we want, apart from that we'll have the unnecessary fields and unnecessary data also. So instead of analyzing the data on that tables, so generally we will use it as a staging tables. We will load first, we will load the data underscore stagings table. So from that, whatever the fields we needed, so we will load into the main table. Suppose the staging table is kind of SETD table, so every time if you are writing the queries, it will take time. So that's why what we will do is whatever the fields we needed just for extracting the fields, so we will use as a staging table, and what are the fields we needed, simply we will copy to the main tables. So main table will have data like a comma separated, it will be there. Whenever we are writing the query, so directly it will fetch the data. So like that we can move the, we'll maintain the staging and maintain tables. So whether we need to compulsory use the staging and main table, so that will be depend on the project. Suppose we need all the fields from the input data, and then we can directly go for the main table. So that will be depend on the project. So once we loaded the data into main tables, then we need to analyze the data by using group by operations and whatever the order by limit, so descending ascending. So we'll use all these things in the queries and we'll analyze the data. Finally results table, we'll store the data into some results table in a Hive, we can store it. So after that, once we analyze the data, we need to, if you want to visualize, so we need to store somewhere. So directly connecting to Hive tables and connecting to dashboards, it will take time. So why it will, that is not the correct way. So and that is not efficient way. So why means if we want to get the data from the Hive table, we need to initiate the map reduce program and we need to get the results. And the results table, whatever we are talking, the analyzed data, it will have only the less data and less fields. Generally we'll have a hour wise page counts and hour wise number of hits, so it will have very less fields and very less data it will have. But whatever the input data we are passing is used, but the result data is less. So this data we can able to handle with MySQL also. So for that what we'll do is, so if you have the less amount of data like less than the gigabytes and gigabytes of data, MySQL is always the very fast for connecting the applications. So for that purpose, instead of directly connecting to result table to the dashboards, so we will load the data into the MySQL by using the scoop. We can load the results table into this. So here instead of the scoop, if you want to use, if you already idea about the JDBC and connecting to the Hive and RDMS, so that is also fine. We can, if you want to use JDBC and you can able to write the queries from Hive and inserting into MySQL, that is also fine. But mostly the Hadoop components wise, we will use the scoop. And once we have the analyzed data, so next step is we need to visualize the data. So for visualizing data, we'll connect it to the daily events, and if you want to visualize the data, so I can connect to MySQL and whatever the data, whatever the particular day information or reports I want to show, I can visualize. So apart from this MySQL, some of the visualization tools are reporting tools. If you want directly instead of the storing into MySQL, so like a dashboards, directly if you want to connect it through visualization tools or report tools, if you want to directly connect, so what we can do is we can directly connect it to Hadoop. So we can make the JDBC or ODBC connection to the Hive results table. and we can load the data. So I think Tableau is supporting connecting to Hive data store, and some of the reporting tools also supporting to connect to Hive. So if we want, we can connect it to the results table also, we can connect. So this is the flow generally what we'll do. So in this one, we will work on, so on daily basis, what we'll do is, so we will initially we will implement some of the, what are the insights we need to make. We'll make the Hive queries, or if we needed pig, so we will make that one and we'll deploy into the, we'll test into development, and then we will load into the production. So production loading, production deployment is nothing but loading the jar files and Wuji workflow, and what are the Hive queries, pig skips we have used. So we need to load into the some location and we need to start the jobs, and this is the flow. And if I want to do this job, so whatever the loading files into HDFS, and then process analyzing the data, and moving to the MySQL and visualizing data. So if I want to do this like a daily, so I need to execute manually. No, we can do by using the automation, or we can make the workflow and we can do it. And we can, if you want to schedule it daily or monthly or weekly, if you want to schedule it, so we can schedule it. So whatever the flow we have defined, loading data, and loading into Hive tables, and analyzing the data, and creating staging and main table, and loading into scoop, so entire this flow we will define it in workflow and we will schedule it. So the production, generally what it will do means, once we design the flow, we will move to the production. So daily data it will come into production. So this process it will be keep on going. So this flow generally it will execute in production. Suppose if any bugs came, so you'll pick that one and we will test into development. It is related to environment issue, or it is related to code related issue. So we will analyze that one, and next, so we will start implementing and we'll test it in development environment. And once the issue is fixed, so after that, after every 1 month or 2 months, we'll push to the production and we'll test again, so whether it is running. Apart from that, daily we'll try to implement new things, and supporting more files, and supporting different kinds of data sources. Like, as only instead of supporting MySQL, sometimes we need to get the data from the different kinds of databases like Oracle, DB2, Netezza, and kind of different data source we need to get. So that kind of things we need to implement, and supporting more files. So that kind of things we'll do it in daily basis. Okay, this is fine if you have the only the Hive, and apart from that, if I want to include the pig, so where it will include the pig, that I will next flow we'll see that one.
Uh, Hello, Srinivas. Could you tell me once again what does it do? The staging tables, what it defines, as well as could you elaborate main tables and result tables, as well as JDBC, ODBC connected from by using Tableau to direct results tables?
Yeah, we can do it. That means we will make the JDBC connection to the Hive, and we can access the result tables.
Yeah, yeah. I understood that. What I'm asking is if the data is a sample one or simple one, we can use JDBC by using JDBC, ODBC by using is it Tableau one, else a scoop.
Okay. I will repeat it again. So
Okay.
yeah, 1 minute. Yeah. I'm getting some questions. Okay, 1 minute. So first we'll go through this one. So staging table is nothing but whatever the input data we are loading into Hive. So that generally we'll call it as a staging table. So sometimes we won't hear this word, and some of the times we'll hear the term called as staging table. So staging table means wherever we are landing first, so input data, so that will call it as staging table. As I said previously, so sometimes we don't need of the staging table. That means suppose if I want to load some raw data into tables, I don't want to use all these things. If I want to analyze the data, so for analyzing, if you have the unnecessary data and anything, so whatever the data we need, if you want to filter that, so from staging table, I will filter it. So whatever the fields I needed, and I will move to the main tables. So that is what we will do it at this step, staging table to the main table. Input data define fields. Yeah, input data, it will have the data and it will have the lot of fields. Apart from that, whatever the fields we need, apart from that, it will have the lot of other data also. So instead of whatever analyzing on the these tables, so what we'll do is we will get the whatever the information and we'll move to the main tables. So like that we will do it. Suppose if I use some SETD kind of concept here, like JSON SETD, so every time if I want to executing on this one, this SETD needs to be converted as a program and it needs to be executed. So it will take time instead of the, if we have directly the data we have the comma separated will have, so it will be more executing, it will be more fast. So that's why we will load the data as a main tables, nothing but a, so whatever the data we need exactly the data, it will be there as a comma separated, the data it will be there, and from that this step sometimes it will be there. So result tables is there means whatever analyzed data, so if we want to store, we will store into results table. Otherwise directly moving this data to scoop also, if you want we can move the data output of that one. If you want to move that, we can move that data also. If you want, we can move. Otherwise this main table data we can store into some HDFS location, and that location maybe we can move to the this Hive tables, we can move it. So generally whatever the output of the this, we'll call it as a results table. So that means analyzed data will store into some tables, so that tables data will move to the RDMS. We can able to connect and we can able to visualize. So here two ways will be there for visualizing whatever the way I'm telling. So if you want to use MySQL and connecting data, we can use it. And data sources like a visualization tool like Tableau or ClickView, if we want to connect directly, we can connect to Hive and we'll fetch the data and we can display into the visualization tool, we can display it. So either the MySQL we can do it, but if we are using the frameworks, mostly we'll go for the MySQL. Suppose if I'm using like a Java frameworks for the visualizing the data like JSF or Spring, so mostly we'll connect it to MySQL and we'll load the data. Instead of connecting to Hive tables, it is not that much of the easy way. So that's why, so running the Hive queries using the Java code, and it will be not good. So that's why what we will do is, so general will load into MySQL and we'll connect it to dashboards and we'll visualize the data. So another way is, if you want to connect it to the Tableau or the any one of the visualization tool or reporting tool. So by using JDBC or ODBC, we can connect to Hive. So if we are able to connect to Hive, so we can connect it to whatever the tables we want. So and we'll fetch the data and we'll visualize. Okay, next I'm moving to the next project. So this is also same, like we'll have the same, we'll have initial, we'll have loading is same. So processing side, I will have mapped this. So if I have the pig, suppose if I want to, instead of maintaining the partitioning and instead of maintaining the staging tables, so instead of maintaining the staging tables in Hive, suppose if I want to filter it in by using pig, if I want to read some input data and I want to apply some of the conditions, so these data only I need it. And that data, if you want to do that one, so simply we'll connect it to the HDFS, and we need to write the pig script files for analyzing the data. So that means we need to write the pig script files for analyzing the data. So in pig scripts, we will we will we will write the commands for the data flow. So here I am using two terms. One is data flow and one is workflow. So whenever I'm talking about the workflow, so coming to the pig, in pig generally we'll use the term like a data flow. So and Woozy we are using workflow. So what is the difference between the workflow and data flow? So pig will do as a data flow. Data flow is nothing but, so what are the steps we need to write for the processing the data? That means load command and filter command, group by command, order, limit. So this is the data flow we will write in the pig, and script files we will write. So first, which relation we need to load the data, and then what we need to for like a filtering, group by, ordering, limit, if you want to joins. So that flow will define in the pig. In the point of Woozy, workflow means we will specify the order of the jobs. First is HDFS job, and the next is the MapReduce job if you want, or if you want to execute Hive, then if you want to execute Scoop job. So that will call it as a workflow. And data flow is nothing but the flow of the data, how it needs to be processed. So the data flow will define in the pig scripts, and will perform the operations like grouping and joins will write. So pig script files read the data from the HDFS and analyze the data, and finally this is output. Finally output will store again into the HDFS. So HDFS, the final output, again it will, the one of the HDFS directory, it will be stored. So like this we'll have the script files. Now whatever the operations I want to do in I did in pig. So what is the next step? So if we everything whatever we need we have analyzed with the pig, and it is moved to the HDFS. So next step is loading into our DMS. That means we can load the directly whatever the data in HDFS output path. So whatever we got from the pig output, we are stored in HDFS. So that data mostly it will be as a comma separated. So that HDFS data, if you want to load it, we can load into MySQL. So whatever data we have analyzed, if we want to visualize, so one way is directly we can load the HDFS data into the MySQL, and we can send to the visualization. We can use it for the visualization. And apart from that, like previously, if you want to connect it to instead of that, if you want to connect it to visualization tools, so then I can give whatever the HDFS data is there. So I can give to the Hive. So here if you see, if we want to connect it to report or visualization tools with Hadoop directly, we need to create external tables on pig and analyze the data, then open the JDBC or ODBC connection to Hive tables and visualize the data. So if you want to connect reports or visualization tools with Hadoop directly, and we need to create external tables and pig analyze the data. First step is connecting the table. So here in this step we don't want any the results table and staging table. So directly the output whatever it is be analyzed by the pig. So directly we are creating external tables. External table means here we are not loading any data newly. So whatever the data it is there in pig, so directly we will create external tables. It will point to the whatever the pig is written into HDFS. We'll create external tables. So that way it will be pointed to the visualization tools. So like that we can, if we want, we can visualize the data. Yeah, actually the year, yeah, one thing is, so Tableau won't can we are not able to connect it to the pig directly the Tableau. So why means pig is don't have any meta store. Suppose if you want to connect it and if you want to make any ODBC JDBC connection, we need some RDMS database. How you have the metastore as a RDMS database. So then only we can make JDBC ODBC connection from the Tableau or the reporting tools. So that's why only we are connecting through Hive only JDBC ODBC. Pig don't have that kind of metastore anything. So it's kind of the processing, it's kind of analyzing tools. Internally it will use MapReduce and it will process it. Give data and tell the steps what needs to be do and tell me the where I need to store. So these are the things we need to tell for the pig. So pig it will read the input data and it will analyze whatever we need and it will store into HDFS. So that's why we are not able to connect it to Tableau directly to the pig. So this is how different ways. So whether I need to use only Hive, whether I need to use pig. So depend on the data. So we can either Hive or pig. So this is if we are using the pig, so how we can load into thing and Hive. So we are not able to connect it to pig to Tableau. So we are not able to, not possible. So I think you think about logically. So if you want to make the JDBC or ODBC connection, what we need the some RDMS database. Pig we don't have any metastore or RDMS. So that's why we are not able to make any connection to pig. Yeah, if Metastore has we can connect, but the concept is pig we don't have the thing. So Hive only we have, so we can connect. So that's why only before the Hive I have told this step. So move the whatever the data we have analyzed with the pig. So we will move to the HDFS. So that data will move to the MySQL. From MySQL we will visualize the data. Yeah. So this is the two ways. So if we are using the pig and if we want to visualize whatever the data it is getting from the pig, so load HFS data to the RDMS and we can send to the reports or the visualization. And suppose if we are using the Hive, directly we can make JDBC or ODBC, or if we want to install the reporting tools, if we want to show some dashboard kind of thing, we can Hive also. If you want to load, we can load into MySQL and we can visualize the data. So whatever the steps I'm telling is, so that will be depend on the project flow and the kind of the data. But these are the different ways we'll use it in real time. So how we'll finally we are moving to the reports and visualization me. So these are the ways. And till now what I'm telling is, so it's kind of the batch processing or batch analysis.
Yeah, it's a general doubt. If I have 1 petabyte of JSON file, okay, so
Okay.
I can process it using Pig or Hive, right? Like in the both the ways I can do it. But what is the best practice? I mean, either to use Pig or Hive, which does the processing faster?
Uh, Processing wise, I think if you want to just analyze the data processing wise, I think compared to that one, Pig is faster. So Why we are going for the Hive means, so if you want to connect it to the different kinds of outside, if you want to outside world, if you want to connect, so pig we can't connect, and through Hive we can connect. So pig we don't have the kind of getting meta information from the meta store and processing it. So pig what we'll do is simply we'll get the information from the name node and we'll send to the map reduce and we'll process it. So and it will enable kind of the parallelization it will be there in both Hive and pig. So the main thing in pig is simply if you want to process the data, so in that case we can use the pig. Suppose if I have the JSON data, simply I want to analyze, I don't want to maintain the previous data and I don't want to connect to the outside world, so just I want to process data and I want to store it again back to HDFS. In that point of view, always the pig is better, pig is good. And instead of that, if I want to maintain the daily coming data and if I want to connect it to the outside world, that means if I want to make JDBC and ODBC kind of the connection, and if I want to connect it with Impala, and if I want to connect it with HBase or the NoSQL, so in this all point of view, if you want to connect to outside world, so the Hive is the better thing. And instead of that, simply if you want to process, we need to use pig. Okay, 1 minute to the Hive. So if you want to maintain the suppose 1 year data as a different partitions, and I want to maintain data, and if I want to connect it to outside world, and if I want to make the JDBC ODBC connections, and if I want to maintain the connecting to Impala or HBase and NoSQL databases, so in that point of view the Hive will prefer the Hive. So based on the kind of the usage, so either pig or Hive we can go for the processing wise. I think the uh, pig is good. And here one more thing is, so that will be depend on the processing engine also, either the pig or Hive. So till now we are talking about the processing engine only, the MapReduce, but it's instead of the MapReduce they are introducing the new kind of the processing engine like Tez and Spark also. So in that point of view, the instead of connecting to MapReduce, so Hive also it will be have more performance when we are processing with terabytes of data.
Yeah, Srinivas, one question.
Yeah.
So you're saying that one, the pig is just for read the data and send it to the HDFS.
Yes, read and
Then
analyzing the data.
up,
So
read and what are,
whatever the steps we have specified in pig scripts, it will perform that operations.
okay. So in that in Hive, so that send the data means pig, it's HDFS only, right? Finally.
Yes, yes, yes.
Okay, same thing in Hive also. We are partition means if suppose we have the table data, so 1 year data we part HDFS. Instead of that one, you're saying that one metadata store in Hive. Temporarily, it will store some time in the Hive.
No, Metastore we are using as a, I think previous classes have explained. So Metastore we are storing into MySQL. So it is permanent only.
Storing MySQL, then again finally will send to HDFS. Sorry, HDFS.
No, no, no. Data we will store into HDFS. Only the meta information will store into Metastore.
Oh, okay, okay, okay.
I
Okay.
think previous when we are discussing about Hive also, so we will have the two phases. One is storing data and storing metadata. So storing data, it will be stored always it will store into HDFS only. If you're using Hive also, so Hive don't have any storage. So it will store in HDFS only. But where the data is stored for the particular table, that all the information it will maintain into Metastore. Metastore
Uh,
is the permanent information, so it will be stored, we will configure as any one of the RDMS like MySQL we have shown in the training classes we have shown that.
okay, okay, I understood. That's what the Metastore kind of thing. So database you are saying that one. Okay.
Yes, so that is the permanent. So whatever we are talking about the connecting outside means, So if the meta store is a kind of the RDMS, so we can connect it to outside world. Like if you want to connect to the reporting tools, we can make JDBC connecting to the meta store, and while connecting, what it will do is it will make the connection to the meta store. So meta store, it will have the information about the where the HDFS is there. So we can connect it to the HDFS and we'll read the data and we'll display to the visualization. It will possible in Hive.
Okay, I got
But
it.
pig, we don't have any meta store kind of concept. We don't have. Simply read, uh, analyzing. Analyzing means we'll write the scripts and storing again into the HDFS.
Okay, thank you.
Yeah, yeah, Srinivas garu, sometimes it is very difficult for me to talk in English. The thing is, the problem I'm unable to express to you. So that's why I'm asking in Telugu.
Okay, okay, no
So
problem.
yeah, don't mind. Well, uh,
Okay. So the job of scoop or flume is injecting the data into the HDFS. Suppose if I have data in RDMS, use the scoop and inject the data into HDFS. Suppose if I have data, continuous data like servers or the like Twitter website, if I want to read the data, or the social media like website, Facebook or Twitter, if you want to read the data continuously and if you want to load it, so we can use it for flume. And here one more thing is flume. I think we don't need to schedule anything. Every few minutes we'll specify the flume. We can configure it every 1 minute or the 5 minutes if we want to connect this server logs and read the data. So that we can configure flume itself. But apart from the flume, so if you want to configure like connected to every 5 minutes, not 5 minutes, every 1 hour or 1 day or 1 month, so we can connect it to the input data and we can process it. So here if you observe one more thing is, so why we are not doing all these steps for every 1 minute 5 minutes means, so pig and hive is kind of, it will be batch processing. So every time it needs to be convert as a MapReduce jobs and it needs to be converts. So that's why only we are not doing the real-time process with the Hive, Pig or MapReduce. So basically we'll connect it, we will execute whatever the flow workflow we are designed. So we will execute for every hour or every day or every weekly or monthly if we want to execute. So like that we'll execute this Hive, Pig or MapReduce jobs. So here the point is Flume, we won't interact with directly to Hive and Pig. Flume job is we'll have the source and sink. So from which source to which sink. Sink is nothing but a HDFS, and which folder we need to load the data. So that will configure it in Flume. So continuously it will fetch the data from the server logs and it will load into HDFS. I think till now we didn't discuss about the Flume. So after this, we will next session we are going to discuss about Flume, UG we are going to discuss. So that time you will get more details about the Flume. So in this flow, here I'm going to change. Here I have changed the input data also. In this project flow, instead of the text files, I'm loading. Suppose my data is coming from Excel or Word files. So directly, I'm not able to process using Hive or Pig. I'm not able to directly process Excel or Word or PDF files directly in Hive. So in that, what I will do is I will write the MR code, MapReduce code. So this MapReduce code, what it will do is, so write MapReduce code to convert Excel or Word files into CSV or any delimiter data. So this whatever we have processed with MapReduce, so this data we can pass to the Hive and we can able to analyze the data. Suppose if I have the Excel files and Excel files having the different tabs. So each tab having the some of the fields about the particular, suppose if I have one product. So first Excel tab having some information and the second Excel tab is having some other information related to same product, but it will having some fields in one tab, some fields in another tab. So I will read the data by using MR code, and I will output I will send to the as a comma separated and the delimited data I can load it. So by using MapReduce, we can convert the Excel Word file into CSV. So if we got the CSV or any delimited data, so we can pass to the Hive. So the only step here is additional, we are writing the MR code and we are doing. So here also whatever I'm talking about the different tabs, for each tab I can create one separate table, like that we can call it as a staging tables. And so now what I'm going to do is my data, whatever the product information, it is not in single file and it is not in single Excel tab, it is on different things. So that's why I'm loading the different files, different kinds of files information or different Excel tabs information into different tables. Finally I need to get the single product information, and here what I'm going to do is, in this project flow, my aim is not analyzing the data. My aim is integrating the data from the different Excel tabs or different Word files and making as a single record. So whatever the data it is there, full data I won't be there in the single Word files. Suppose if my suppose I have a one product, so that product, some of the information it is one A Word file and some of the information B Word file. So now I want to get the full product information. So for that I need to integrate all the different kinds of Word files and I need to make as a single one. And this information I'm going to store into NoSQL, not the MySQL. I'm going to store into NoSQL. And why this use case or this project flow, why I am using NoSQL, why I'm not using MySQL or RDMS, why I'm not using RDMS, why I'm going for the NoSQL. Here the use case what we are handling is, here we are not analyzing the data. So analyzing the data means it will get, finally will get only few records, but here not, I'm going to not analyzing the data. So what I'm going to do is I'm going to perform some transformations on the different tabs or different Word files data, and finally I'm joining the different tables and I'm making as a single table. So this full entire table information I'm loading into the load Hive tables data into NoSQL database by using the external tables or Java API. So yeah, once after completing that one, I will explain again. So we are loading into NoSQL. So these are the some of the NoSQL databases like HBase, MongoDB, Cassandra. So we'll have the different kinds of databases in the NoSQL. So that more details I will discuss in the next classes. I'm going to discuss after completing the Flume or the after this MapReduce things. We'll continue that one. The NoSQL will continue that. So now I've stored into NoSQL, and instead of the visualization, what we are doing is we are connecting our applications to the NoSQL. And if I want to fetch some product information, suppose if I type the product, I need to get the whatever the information it is as passed as a input in a different Word files. I need to integrate and need to store as a central location. And if I my website, if I entered as a some product information, product ID, I need to get the all the information which I insert as a Excel files and Word files. So this is the different use case from the last two. project flows. This is the one kind of the use case. So instead of the passing only text file, so why will load the Excel files and Word files? Suppose if you take the any manufacturing companies kind of things, so they will provide the information as a Excel or Word files they will give. So that information, if you want to load into some central database, and if you want to check by using entering the some product ID or something manufacturing ID if you given, if you want to get the data, so in that point of view, so directly loading this is the one of the use case. So reading the data from the different kinds of files, Excel, Word, PDF, any kind of file, we can read it and we can store into HDFS. And if we are not able to process with Hive or Pig, we can convert as a MapReduce. By using MapReduce code, we can convert as a some standard format like CSV, and we can pass to the Hive, and Hive will pass the different data as a different tables, and we will perform the transformation. So what are the fields we need to integrate, so we'll make it as a one main table. So this table will have the full product information, so that it will be stored into central location NoSQL. Coming to the NoSQL, so NoSQL, why here use NoSQL means, suppose my input data product having the 100 fields, or if you are having the more than that, so in that point of view NoSQL is better. If you have the more columns and some of the fields don't have the some of the columns, and some of the fields having the more columns, so in that point of view NoSQL is good. That means NoSQL don't follow the any particular schema. So particular table needs to be contain this much of columns, and each row must contain this much of columns, though. So that kind of rules don't have it in NoSQL. And one more is distributed. Suppose if I want to store the 1 lakh Excel, 1 lakh PDF files, I have the lot of manufacturing customers I have. So in that point of view, so we can store the all the data as a one NoSQL database. It's kind of centralized, and from that I have the common website. I want to see the what are the products are generated and manufactured from the different countries or worldwide. Simply I can see through web application whatever I have, I will search product ID, I can get the information. So this is the one kind of the use case. Instead of analyzing the data, if you want to store the kind of transactional, so whatever the previous use cases like Hive or Pig, directly it is not supporting the kind of transactional. So it is not supporting. But if you use NoSQL, we can support. It can having the more fields, and it's kind of distributed. We can store the more data. We can store if you have the more columns data, and if you have the more records, so we can easily store into NoSQL, and we can connect it to. So this NoSQL databases directly, it's kind of databases, so we can directly connect it to the web application like transaction. If I want to get some record, I can connect it and I can fetch the data. But this application we can't connect it to either Hive or Pig, we can't connect. So the why means, so it won't support to connect it to applications. So that's why we are loading into the entire data into NoSQL, and we are reading it. So whatever we have initial the demo classes, and whenever we are started with the big data or Hadoop, we are big data, we have seen the three parameters like volume, velocity, and variety. So previous two use cases, it is handling the large volumes of data. Previous two use cases. This use case is handling the different varieties of data if you want to supported by the applications. So the Hadoop, if you want to do it, so how we can do it? This is the one of the use case. So generally we'll use it. And finally, so if application needs any data, it will connect it to the NoSQL database by using the REST API. If you have idea about the REST API, we can connect it from application to NoSQL database, like how we'll connect it to RDMS. Similarly, we can use the REST API calls and we can get the data. Instead of that REST API calls, we will have the Java APIs also for connecting the NoSQL, and we can connect it to that, and whatever the data if we want to see, we can get the data. So this is the one more the kind of use case and the project flow if you want to load the Excel files, and if you want to see the all the Excel or PDF files information, the data into particular website, if you want to see it by using typing some ID or some other information, and we can connect it to some centralized NoSQL database, and we can get information, we can able to see. Got it? Shall I explain again?
Hello.
So the
Yeah, good.
yeah. So I think she added very good points. So why we are using MapReduce is converting, and we are making as a one standard format from the different input files, and that standard format we are giving to Hive, and each table we are giving to one, it will represent to one tab or one different file in Word file, and the tables, and we are integrating the tables, we are doing transformations. And here if you observe it, we are not storing NoSQL into only few analyzed columns. Whatever the input data is there, entire the record or entire the all the things we are storing into NoSQL. Why means while displaying, I need all the information. I'm not going to analyze. So I'm going to display whatever the product information I want. I want to display all the data for the particular product. So that's why I need all the columns, and I need the all the records from that one, and I'm showing into NoSQL, and whenever it is searched, so it will be get from the NoSQL and it will be displayed.
Different kinds of
Like what are the use cases? So whatever I have explained the things, so we can apply for these use cases. So every use cases, it will have this kind of the flow only, whether loading data, extracting the data. So whatever the data, it is retail, financial, e-commerce, government. So any kind of the data, it needs to be having some format, file format. So we need to maintain the format, and how we need to load the data, where it will be there, and how we need to extract the data, and loading the data and analyzing the data and visualizing. So finally, we need to improve the business, and the analyzing the data, we need to analyze. So after that, whatever we are visualizing, on that if we want to perform the machine learning or the predictive analytics kind of the algorithms, like uh, the example is how they are predicting the, if you go to the LinkedIn, how they are predicting the friends. So maybe you know this friend, so how they are predicting means they are matching some of the education, some of the company location, they are matching and they are predicting, so maybe you will know. So that kind of predictions will happen by the predictive algorithms or the machine learning kind of the algorithm, so they will predict something. Yeah, these are the use case. Okay, coming to the questions, the first question is, in our company or organization, so what kind of data we will store? So this we already discussed these things in the previous slides. So text or GZ, JSON or Avro, and REST APIs and applications like social media. So these are the different data we will use. So based on the different kinds of the input data and clients, we'll use any one of the data. So whatever I'm explaining is, I'm not pointing to single use case or single project. So it will be related to the overall and different kinds of the use case and different things. So simply if I'm taking only one project and explaining, so instead of that, what I'm trying to, this main aim of this session is, so in real time if we go for doing the Hadoop project, so what are the things needed, and if the what kind of data it will be there. So for that overview, I have taken this session. And if you are going to take one project, and then you can easily get the what are the things we need to cover it in I'm explaining different kinds of data types and different use cases I'm explaining. Okay, next point is generally we'll get in your project for your you will get, so in your project where you will get the data and who will give the data. So that will get from the, either will get from the customers, they will store, they will load into the remote files, they will load it, or if we want to connect to web servers, we can connect to web servers. And data, it will be in different data stores. Suppose if I want to my if I have one client, that client having different stores in different countries, they are storing the data in different data stores. Some of the countries they are using Oracle, some of the countries they are using MySQL, and I want to integrate the all the different kinds of the uh, data stores. So then I can connect it to the different data source. I need to integrate all the data, and I can store into one central location. I can store it. So in that point of view, we need to connect with different data sources. Instead of that, I need to connect it with web logs. I can connect it with the web servers. And the next question is how will connect it to your Hadoop cluster and work on it. So that means suppose if you go to the project and things, so how we are connecting to remote database. Similarly, if you want to connect to the Hadoop cluster, so we can connect it by using the putty, or if you want to transfer the files, we can use the WinSCP. Which server you need to get data from which servers, what servers you need. Web server or any server, if you want to get the continuous data, we can use Flume and we'll get the data. What other servers you need to get data? If it is continuous kind of data, you can connect it to the Flume and we can get the data. Suppose if the data is a files in remote, you can use the SFTP or NFS, or if you use the HDFS commands and load it. If it is the data sources, you can use the scoop and you can load it the data. Suppose if you have the data servers in US and if you want to load the, suppose my cluster in India, and if you have the web servers in US, simply you can connect it to that by using the Flume, and you can read the data from the servers and you can load into whatever the cluster you are in India. So you can load that data from US servers, web servers to the Indian Hadoop cluster. We can load it if we want. So this point of view, you have any questions or you need any clarification? I will, okay. So why we are using that Putty or WinSCP means I have the cluster in, suppose I'm in Hyderabad, my cluster is in Bangalore, and now I want to execute some Hive queries or MapReduce code. I will connect it to that Bangalore cluster, whatever it is there. If I want to connect to that, and if you want to write some map or code, or if you test, if you want to test, not writing, if you want to test whatever you have written jar files, or if you want to test the whatever the Hive queries you have written, if you want to test it. So for that purpose, by using putty, we can able to access that machine and we can execute the Hadoop jar command into that machine, and we can write the Hive queries. We can write there and we can execute it. For that, we will use the putty for executing the commands or the queries remotely. WinSCP, if you want to transfer some files to remote location, we will use the WinSCP. It's kind of UI, it will be there. I will show, I think previous classes I faced some issue in my laptop. I'm able to fix that now. And actually previous class I want to show that one. If possible tomorrow I will show that putty and WinSCP again. So now I'm able to connect it. So I will show it tomorrow if you want. So this is for the just for the working purpose. If you want to connect to remote and if you execute some command or if you want to transfer. So for that purpose we'll use putty and WinSCP. Apart from that, if you want to load data from the remote servers, web servers, in that point of view, we'll use Flume for loading remote data into the whatever the production or development environments. If you want to load that data, in that point of view, we'll use Flume or SFTP if you want. We can use SFTP for connecting the different remote missions. Okay, coming to the next one, how much data size in our cluster? Maybe this will, it will take a little bit time to understanding, I think, but we'll try to see. Go through this one, these points, and okay, before going to that, I will go to one by one. So you need to say the answer based on the daily income data and duration of project timing. How much data size in your cluster? So now daily, if I'm getting 30 GB per day and the application is running for 6 months, so I can say monthly it's 1 terabyte and 6 months it will be the 18 terabytes. Why it is 18 terabytes? So monthly we are getting 1 terabyte, so 6 months you'll get 6 terabyte. But if we consider the replication factor 3, 6 into 3 will get the 16 terabytes of data. If we use any compressions, if suppose the data size will be reduced to 20%, so then we can, the data it will be, the data size we can say as a 40 to 50 terabytes of capacity. So if anyone asks about what is data sizes, you can say daily we are getting this amount of data and the project is running for 6 months or 1 year. So that's why we are having this much of data sizes in our cluster. This is clear to everyone or anyone need clarity on this one? Yeah, I think everyone is clear this one. So generally they will ask the questions like how much data size and what is your production cluster size. So sometimes they won't mention the production, simply they will ask the cluster size. In that you can say the answer like that. We have the development cluster and production cluster. So mostly whatever we are implementing, we won't interact with the production cluster. So production cluster, it is the real-time data. So once we finalize the flow, it will submit everything. If we'll deploy everything in production. So while implementing the code, mostly we won't touch with the production. So whatever we are implementing, we will touch with the development. So generally the development cluster, it will have the 4 to 5 missions. Sometimes maybe it will have 7 missions, 10 missions. So generally it will have 4 to 5 missions. If you want to test your mapper job or the your Hive queries or Wuji, anything if you want to. So generally it will have 4 to 5. But coming to the production cluster size, it will be depending on the incoming data size and the duration and hard disk size of the each machine. So depending on these three things, so we can use the production cluster size. So first we need to, what is the application is production, how many months it is running the application and daily we are getting, and the each machine how much the capacity it is there. Suppose if I are having 2 terabytes, how many machines are there? So as we discussed previously, we are getting the total, if we are getting the total data size as 18 terabytes, each machine capacity is 2 terabytes. So then how many missions? Maybe I need 9 to 10 missions needed for this. And future, so till now we are running the application, we have the capacity, but what about the future? I want to continue the application for 6 months or 1 year. So in that point of view, I can say 10 more missions. So total I can say as a 20 to 25 missions I have the cluster. So this is one kind of example. Suppose if you're saying the daily, I'm getting this kind of data and my application is running from this month and future, including the future also. We need to continue the for future also 6 months or 1 year. So based on that, so if the application is running from for 6 months, so 10 missions are it's already used, and for the upcoming 6 months if I want to use, I need 10 more missions. So 10 plus 10, 20, and few more missions they added for the some more the future purpose. So that we can say as a 20 to 20 missions cluster I have it. So this is how you can, if you want to say the how the production cluster size, you can make one example, and whenever you Anyone having questions in this slide? The data size and the cluster size? Yeah, okay, cool. A little bit, what is your development cluster size? This one we already discussed. 5 to 7 missions, you can say some cluster will use for the development purpose. So how to transfer large database? I think we can say by using SFTP or NFS tools. Is it your project in production? Yeah, yeah. So whether they will ask like a question like that, uh, suppose whatever the project you have worked, it is in production. Suppose if it is in production, so how can it is automated? So means the answer is yes, it is in production. It is running from 8 months, and we have used Woozy. That is not Woozy. The spelling is mistake. So the tool is we have used Woozy for scheduling the daily or daily base or weekly base we have used. So that we can say automation in production. Okay, what distribution are you using for your project? You can say Cloudera, CDH5, Atomworks, HTTP2, and what Hadoop versions are you using for the your project and why? So we can say Hadoop 2.x versions. It has high availability, federation, and YARN for the resource handling, effective resource handling or sharing. So these are the general questions like what distribution or what Hadoop version, and apart from that, what are the tools you are using? So why you are not using Pig? Why you are not using that tool? So that kind of questions it will be there. I think now I hope I think you have confident on that explaining that. So why you are using in your project Pig? Why you are not using Hive? So why you are not using uh, connecting to loading into MySQL? Why you are directly connecting to Hive? So I hope you have clear idea about that one. Okay, what kind of process handled by your project? Maybe this will be not meaningful, but by seeing answer you will get the clarity. So the processing. So whatever we are showing the till now the use cases we are everything we are doing bulk processing only. So now the latest demand, some of the companies are latest R&D is going on the streaming processing. So that we have the tools like Spark streaming or the Storm or Kafka. So these are the few tools are demanding for the stream processing or continuous data processing. So whatever we are using is batch processing. Suppose if they are asking about, see what kind of processing you are handling in your project, means it's kind of bulk or batch data processing. And which Hadoop architecture you are using? Nothing but Hadoop 2. And what is your project flow? You can explain the detailed explanation about where your data is getting, how it is loading, analyze. So you can explain the clear things each step. How do you test the mapper code and Hive queries or pig scripts? So if you are asking, if anyone asks about the I have written some code, mapper code and Hive queries, pig scripts. Local mode, if you want, we can test it in local mode. But whatever we are testing in local mode, I think that is we are not sure whether it will be work on HDFS. So that's why if you go to the development cluster and if you tested it, so we can, if it is everything is working fine, we can say we can ready to move it to production. So by moving the jar file, Hive queries, pigs to development, by using, if you want to move to the development environment, what are the files, if you want to test it, we can use WinSCP or FileZilla to move the files to development environment, we can move it. And once everything is fine in development, then we are ready, we are fine with the moving to the production. So what is the production deployment? What are the things and will do and who will do it? So sometimes we'll talking about the production deployment, maybe in other things like in Java or the RDMS side, maybe you'll have aware about the production deployment. So here what we'll do is we will check the what are the issues we have faced or any new feature we are going to add in the production. So that will move the jar files, queries, pig skips, and Wuji workflow files. So these will move it to the production, and which we have tested in development environment, which is working fine. So we'll move to the production, and generally the admin people will do this, all these moving the things. So we need to specify the what are the paths and what are the files we need to move, and to production we'll make the list and we'll give to the admin people. So admin people will have all the access to copying, deleting everything. So they will move to the production and they will do the deployment. This is all about this session, and I hope everyone got some basic ideas of what we'll do in real time. And thank you.